Hey all. So if you guys didn't know, the AP, the College Board, has been putting out like sample questions, and they've been doing a lot of videos going through these practice sample questions, like these mock exams. And I thought I'd put together my own solutions. You should really check out the AP YouTube site, and watch their videos. They have great teachers. They're great at explaining things. But I have gotten some requests for me to sort of do some of the answers and do some of my explanations to them. So here's mock exam number 2. I'm gonna do question 1. I'm gonna do question 2 in the same video. So we'll see. I only have like 30 minutes to knock out this video. So let's see if I can do both questions in 30 minutes. So f, g, and h are twice differentiable functions with g of 5 equals h of 5 equals 1. The line y equals 1 minus 5/3 x minus 5 is tangent to both the graph at g and the graph of h. Okay, so this is kind of important to remember. What does tangent mean? I kind of in my mind, when I see something as a tangent line, it has the same slope and it goes through the point, in the same point. That means this line must touch g, and it must have the same derivative as g at x equals 5. So g prime of 5 must have the slope of the slope of the tangent line. Well, this is my tangent line. So the slope of my tangent line, what's the slope? What's the number? The y equals something times x is actually negative 5/3, like that. Okay. Let b be the function given by b of x is equal to 2x squared g of x. Write an expression for b prime of x, and then find b prime of 5. So this is making sure you understand conceptually how to apply your differentiation rules. This is, I'm multiplying two functions of x, right? So when I do b prime of x, I have to do product rule. I have to do the first function times the derivative of the second function, plus the derivative of the first function, which would be 4x, times the second function, right? It's just product rule, just in notational form. Okay, so that's my answer for that. And then you just need to find what it is at 5. So I'm going to do 2 times 5 squared. That's 50 g prime at 5, plus 4 times 5, which is 20 g of 5. Okay, I'm just plugging in 5 into my expression here. Now, g prime of 5, we've already discovered, was negative 5/3. So I have that. Now, what about g of 5? Well, this is where we have to look at the... Oh, actually, they tell it to us. Never mind. G of 5 is 1. But I was going to say you can plug it into this point. If you plug in 5 into here, you would get 1. Because the tangent has to touch the point. They didn't really have to give this to you, but I think they just did it for simplicity. And then I don't know, this is 20, this is kind of I would use a calculator, I guess, just to save time. Not minus 253 over 20. 20 is right 60 over 3, and so that's minus 190 over 3, and that's not divisible by 3, so that would be my answer. Yes. Okay. Let w be the function given by this. Write an expression for w prime. Well, what do I have to do here? I'm dividing two functions, so I can do quotient rule. Quotient rule is the bottom function times the derivative of the top. Derivative of the top is 3. Derivative of h of x is h prime of x. Derivative of x is 1. Minus the top function, 3h of x, minus the derivative of x, which is just 1. Minus x, not the derivative, times the derivative of the bottom, which is just 2, divided by the bottom squared. And they usually say not to simplify. Just write this out. This is your answer. Just leave it like that. Don't simplify. They encourage you not to in order to avoid any mistakes. Now let's plug in 5 here. This is going to be 11 times 3 times the derivative at 5. Oops, put a parentheses there, minus 1. Minus 3h of 5 minus 5 times 2 over 11 squared. Now, h prime of 5, you see, because h prime is tangent to this, so it has this, h prime of 5 is the same. It's because this function is tangent to h, the slope, just the same reason this one is negative 5/3. G prime of 5 is negative 5/3. H prime is negative 5/3, so I'm just going to plug that in. Minus 3, and they said h of 5 back in the original problem statement. H of 5 is 1. That's times 1 minus 5 times 2 over 121. And so this is going to be, again, this is going to be minus 5 here. So this is minus 6, it's minus 66. 3 minus 5 is negative 2. Negative 2 times 2 is negative 4. Minus negative 4 is plus 4 over 121. And so that's negative 62 over 121. And that's not divisible by 11, so that's as simple as it's going to get. Again, you can use a calculator for that. Let m of x is equal to this function. Write an expression for m prime of x. Find m prime of 2.5. Okay, so m prime of x is the derivative here. Now, first let's evaluate m of x first, because I have a derivative and an integral. So m of x, what's the rule when I take the derivative of an integral like this? The rule is you take whatever is in here. If the numerator is an x and you're going to plug it into the function g of 2x, then my chain rule, I got to multiply by the derivative of 2x times 2. This is fundamental theorem of calculus. Okay, so this is going to be 2g of 2x. That's it. So m prime of x is the derivative of this. So what's the derivative of this? Well, that's 2g prime of 2x. And then derivative of the inside times 2. That would be 4g prime of 2x. That. So that's my answer for m prime of x. And then they just want you to find m prime of 2.5, which would be 4 times g prime of 2 times 2.5, which is 5. And this is negative 5/3 minus 20 over 3. All right. Let's see. Let m of x be that. It's the same as before. It is known that c equals 2.5 satisfies the conclusion of the mean value theorem applied to m of x over the interval from 1 to 4. Use m prime of 2.5 to find g of 8. So what does the mean value theorem says is that there's a c where m prime of 2.5 must, this is the tangent line slope, must equal the secant line slope, m of 8 minus m of 2 over 8 minus 2. If you look at mean value theorem, it's the derivative at c has to equal the secant line slope. I plug in the endpoint. Oh, sorry, this is not 8, it's 4. I don't know why I said 8. It's because this said 8, and so I think that threw me off. The interval, the endpoints of my interval are 4 and 1, not 8. So 1 and 1 there. Okay, so I have to evaluate m of 4 is. But remember, I've already figured out what m of x is. That's 2 times g of 2x. So m of 4 is equal to 2 times g of 8. And m of 1 would be 2 times g of 2. Right? Just using my expression here for m of x. Right? 2g of 2x. So, so then this expression is really 2g of 8 minus 2 times g of 2. And 4 minus 1 is 3. So I can factor out a 2, and it would make this 2/3 g of 8 minus g of 2. And you see, I just want to solve for this part. This equation from the previous part I know is negative 20 over 3. So to get rid of I divide by 2/3 or multiply by 3/2 to get rid of this. Those 3's cancel. This would be negative 10 is equal to g of 8 minus g of 2. And that's what I was asked to solve for. Okay. The function g satisfies this equation for x not equal to 5. It is known that the limit can be evaluated using L'Hopital's rule. Use the limit of x approaches 5 g of x to find f of 5, f prime of 5, and show the work that leads to your answers. Okay, so the conditions for using L'Hopital's rules is I have to have an indeterminate form. Like I need to have a 0 over a 0. So let's try to evaluate this limit first by plugging in 5 here. So I'm going to plug in 5. It's going to be 5 plus 5 cosine of 1/5 pi times 5 divided by 3 minus square root of f of 5. So this is me attempting to plug in 5. And what if I can use L'Hopital's rule, this needs to become 0 over 0. So what this is becomes, let's see, this is cosine of pi. Cosine of pi is negative 1. So this is 5 minus 5 over 3 minus square root of f of 5. But I need this to be a 0 over 0 indeterminate form, right, in order to use L'Hopital's rule. That means the top is 0, which checks off, right? And the bottom must be 0. So 3 minus square root of f of x must equal 0. Sorry, f of 5. And I can solve for f of 5. F of 5 would have to be 9 then, right? Because square root of 9 is equal to 3. So that's the first part there. Then we have to apply, so then we say like, okay, so I can use this and I can apply L'Hopital's rule to find a limit. So this is going to be the derivative of the top, which is 1 plus 5. Derivative of cosine is negative sine 1/5 pi x, right? And then derivative, and then by chain rule, derivative of the inside is 1/5 pi divided by the derivative of this. Well, this is 3 minus f of x to the 1/2, right? And so I'm going to, derivative of 3 is 0. So this is going to be negative 1/2 f of x to the negative 1/2, doing power rule. Then I got to multiply by the derivative of the inside, which is f prime of x. Right? So that's what I'm doing. This is using L'Hopital's rule. That's what I do. And then I'm going to plug in the 5 here, and I should get a finite limit, I think, because actually this f prime of 5 is a little confusing, because if I plug in 5, I'm going to get 1. Let's see, this cancels with that. It's going to be minus pi times sine of pi. Sine of pi is just 0. And then this is going to be negative 1/2. F of 5 is 9, so I take the square root of the 3, but it's like on the bottom, so it's like 1 over square root of f of x. So that's 1 over square root of 9 times f prime of 5. Okay. It can be evaluating using L'Hopital's rule. This part has to be 1 on the top. And let me see. Like, what did we know about g of x? We knew that g prime of 5 should have been negative 5/3, right? Because it was tangent to this, that this derivative ought to exist. Wait, no, actually, we're not doing g prime. We're doing derivative top and the bottom. Let me think about this. So this is going to be 1 because sine of pi is 0, and then this is negative 1/6 f prime of 5. But I need this to be equal something. I need to know what this limit is. Use the limit. I was thinking I'd take the derivative of this thing. But you see, the thing is this is not the derivative of g of x. This is the derivative of the numerator divided by the derivative of the denominator. And that isn't the same. Let me think about this one. What else did they tell us? So this limit as x approaches 5 should equal g of 5, right? This whole thing needs to equal g of 5. And we know that g of 5 is equal to 1 because they told us g of 5 is equal to 1. So this limit has to exist. It has to equal 1 because they told us g of 5 is 1. So, and they told us it's differentiable. Like, that's the thing. Like, sometimes the limit may not match the... So, because it's twice differentiable, it's continuous also. That implies it's continuous. And what we know about continuous functions is that it must be that this is true, right? Because for every point, if I approach that limit, it's got to equal that value of that function. That's what it means. That's the definition of continuity. And thus, so I know that this limit has to be g of 5, which is equal to 1. And so that's going to like finish out how I can solve this. I know that this has to equal 1. Because even though this is the limit of the derivative, it's still supposed to be equal to the original limit that we would have found. And so this would have been multiplied by f prime. I get f prime of 5 would be negative 6. Just solving this, you multiply this, and then 1 over negative 1/6 is negative 6. Okay, and it is known that h of x is less than or equal to g of x for 4 between 4 and 6. Let k be a function satisfying in between there. Is x continuous at x equals 5? Justify your answer. So we have a k of x as a function between h and g of x. It's looking like they're having you do the squeeze theorem for this, and I didn't remember. I actually don't remember if Calculus AB talks about the squeeze theorem, but it kind of must, because what does it mean to be continuous? First, we need to show that the limit as x approaches 5 of k of x is equal to k of 5. This is what we need to demonstrate. If you can show both sides of the equations are equal, then we know it's continuous there. Okay, so let's do the k of 5 first. Well, I know k of 5 has to be between g of 5 and h of 5, right? It has to be, because this inequality says it's for all x between here. This inequality must hold, especially at 5. And we know that this is 1, and this is also 1. So what that implies is that k of 5 must also equal 1. Because if k of 5 is greater than or equal to 1 and less than or equal to 1, then k of 5 must equal 1. Now let's compute, so this side we know is equal to 1. How about the limit? The limit as x approaches 5. Well, just like before, we can kind of do this. If we know the limit as x approaches 5 of g of x, we know that it has to be greater than the limit as x approaches 5 of h of x. And the reason we know that is because this function, because k is always between h and g, even as I approach x approaching 5, it's that inequality must still hold, right? So this limit we know is true because because g and h are continuous. We know that this has to be g of 5 and that this has to be h of 5, which is 1 is less than or equal to the limit h approaches 5 k of x, which is less than or equal to 1. And so what we've shown is that the limit of x approaches 5 of k of x has to also be 1. And so if the limit has to approach 1 and the function has to equal 1, we've demonstrated that the limit that x approaches 5 of k of x is equal to k of 5, which is equal to 1. And so that makes it continuous. Okay? So let's move on to the second question here. Okay, let's see. That took me a little over 20 minutes to explain, so let's see if I can knock this one out. Let f be the function defined by this, and let g be a twice differentiable function. The table above gives values of g and its derivative g prime at selected values of x. Let h be the function whose graph consisting of 5 line segments. So here's like a standard kind of question. This is a modified question, but they're giving you a table, they're going to give you a graph, and you kind of have to just use like all the information. Find the slope of the line tangent of the graph at f equals 1. That means I need to find the derivative at 1. So first I need to find the derivative of x and then plug in 1, because the slope of the tangent line is the derivative at that point. So f prime of x is going to be, derivative sign is cosine pi x times pi. You can use your calculator to check something like this too. Pi is because of chain rule, derivative of the inside. And then what's the rule for ln is 1 over the inside. And then by chain rule, the derivative of the inside, which is negative 1. Okay, and so then if I do f prime at 1, it's going to be cosine of pi times pi plus 1 over 2 minus 1 times negative 1. And that's, this is negative 1, so this is negative pi. This is 1 minus, so this is 1 times negative 1, which is 1. Negative 1, so negative pi minus 1. So let k be the function defined by this. Find k prime. Okay, k prime of x. This is going to be requiring you to understand chain rule. So I have h. I have the something inside of h. So when I do the derivative of the outer function, I always leave the inside alone, right? Because you don't change the inside when you're doing chain rule. You take the derivative, you apply your rule, and then because the inside's not x, you multiply by the derivative of the inside, which is just f prime of x. So k prime at 1 is h prime of f of 1 plus 2 times f prime of 1. This part we already know is negative pi minus 1 as given before. F of 1 is equal to, we got to use this function. So it's sine of pi x, sine of pi times 1, plus natural log of 2 minus x, natural log of 2 minus 1. That's natural log of 1, that's 0, and sine of pi is also 0. So this part's just 0. So this expression becomes h prime of 2 times f prime of 1. What's h prime of 2? Well, I got to look at my graph. 2 is here. H prime would not be the value. H prime would be the slope of this line, the derivative here, which is this slope right here. And this slope is, let's see, I go down 1 and over 3, so the slope here is negative 1/3, right? So I went down 1, I went to the right 3. And so this is negative 1/3 times negative pi minus 1. And you can just leave it like that, or you can multiply by the negative. Doesn't really matter, pi plus 1. You can leave it like this, though. Try not to simplify. Do as little arithmetic as possible. Okay, evaluate this. This is by fundamental theorem of calculus. This is, I take the antiderivative of g, which is just g. So I plug in g of negative 1 minus g of negative 5. And then I have to go look at how do I find g. G of negative 1 is 1. G of negative 5 is 10. So this is 1 minus 10 equals negative 9. Okay. Rewrite the limit as n goes to infinity as the sum of k goes to n. Okay, so this is a Riemann sum. They actually don't ask this very often, or if ever, that I remember on an AP Calculus exam. So you need to write this as a definite integral. So you kind of have to have this formula in your mind of, this is how it's n goes to infinity. The general form of, it's always f of, and I always do the left point, it doesn't really matter. The first plus I delta x times delta x. This is sort of like my rectangles. This is the height of my rectangle, this is my width of my rectangle, where delta x is b minus a over n. So if you look at something like over n here, like this, you're going to pattern match. This is my delta x, and then this is like, oh, sorry, not I, but k. I usually do it with I. But and then this is k delta x here. So here you can match that delta x is equal to b minus a over n, okay, which is 5 over n in this case. So b minus a is 5. And then this is my a. So this becomes, so a is equal to negative 1. Okay, my b minus a is 5, because that's the width of my interval. So if a is negative 1, then this is b plus 1 has to equal 5, so b has to equal 4. So this would, and then what is this equal to? This is equal to the integral from a to b of f of x dx. So this is going to be the integral of a to b, this is negative 1 to 4 of h of x dx, like that. Like I found the bounds, and I found the width, I found the bounds of my integral, and everything. Okay. So this is of h of x. So this is the remember h is a graph, right? So I have a graph of h. So what does this physically mean in terms of graph? This is the area between x equals negative 1 and 4. Okay. So I need to go from negative 1 here to 1, 2, 3, 4 to find, like, oh no, that's not 4. What am I doing? That's 4. 1, 2, 3, 4. I'm going to find this area here. All this area. So so if I go to sum up this area is going to cancel with this area, so I don't have to worry about it. Like that, like, looks like it's going to just cancel. So I really need this area and then this triangle area. Well, this is a 1 by 1, so this area is 1/2. Positive 1/2 above the x-axis. This area is a 1 by 3. So 1 by 3 is 3, so this area is negative 3/2. So it's going to be 1/2 minus 3/2 is the total area. And that's negative 1. What is the fewest number of horizontal tangents that g of x has the interval? Okay, fewest number is where horizontal tangents where the derivative equal to 0. Let's see where the derivative is equal to 0. The fewest number. Let me see. Well, we by intermediate value theorem, we had to have crossed a 0 here. Okay, and then we had to cross a 0 here. So I have 1 here and I have 2 here. And then none of the, and then I should check mean value theorem, but none of the secant line slopes here are going to be 0. So intermediate value theorem says anytime I had a 0 crossing. So I would have 2 at the minimum. So 2 because by IVT, there must be a crossing you should probably write the whole IVT, a crossing between, I'm sorry, G prime of x, horizontal thing, I'm doing G primes, G prime between -4, -3, and -2 and -1. I don't know how you want to write those interval notations. Sorry, I'm in a little bit of a rush to like finish this video and put this out. But yeah, I think that pretty much sums up that exam question. Yeah, let me know if you have any questions about the explanation there. But I think they have a video going over the solutions too, so you can always check out that video. But this is kind of how I would have done the problem, just like without having looked at it before.